In 2006, a major decision shook the world of astronomy. Pluto was no longer considered a planet. This decision was made by the International Astronomical Union, IAU, during a meeting in Prague, where they redefined what it means to be a planet. For decades, Pluto had held a place in the lineup of planets in our solar system, but the truth is, its status had been debated for quite some time. So why was Pluto demoted? And why did this change stir so much debate, not just among astronomers but also among the general public? The core of the issue lies in the fact that, for centuries, the word planet didn't have a strict definition. The ancient Greeks viewed planets as wandering stars, including objects like the Sun and the Moon. But as our understanding of the solar system evolved, so did the need for clarity. When Uranus and Ceres were discovered in the late 1700s and early 1800s, astronomers were forced to reconsider what qualified as a planet. Initially, both objects were classified as planets, but over time, Ceres was reclassified as an asteroid, and Uranus remained a planet. This same dilemma arose again with Pluto's discovery in 1930. Pluto was small, had an unusual orbit, and didn't fit neatly into the planet category like its larger counterparts. But because it was the only known object in that distant region of space, it was accepted as a planet. However, by the 1990s, astronomers began discovering more objects like Pluto, and by 2005, the discovery of Eris, an object roughly the same size as Pluto, forced astronomers to face the issue head-on. Was Pluto really a planet, or was it something else? The IAU eventually decided that in order to be classified as a planet, an object must meet 3 criteria. It must orbit the Sun, it must be large enough that its gravity pulls it into a nearly round shape, and it must have cleared its orbit of other debris. Pluto met the first 2 criteria but failed the third, as it shares its orbit with other objects in the Kuiper belt. Thus, it was reclassified as a dwarf planet. The demotion of Pluto was not just a scientific issue but an emotional one for many who had grown up learning about the 9 planets of the solar system. For them, Pluto's reclassification felt like a loss. But the decision was necessary to bring clarity to an ever-growing understanding of our solar system. As our understanding of the solar system expanded, so did the complexity of defining what exactly constitutes a planet. One pivotal moment in this evolution came with the discovery of Uranus in 1781 by the astronomer William Herschel. Up until then, astronomers had only recognized the planets visible to the naked eye: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Uranus, with its faint appearance and distant orbit, was the first planet to be discovered with the aid of a telescope. Its addition to the planetary lineup was a milestone, but it also posed a challenge to the long-held definitions of what a planet should be. Around the same time, another significant discovery took place. In 1801, Giuseppe Piazzi discovered Ceres, the largest object in the asteroid belt between Mars and Jupiter. Initially, Ceres was classified as a planet too, joining Uranus in reshaping the solar system's family. However, as more objects similar to Ceres were found, astronomers realized that these bodies didn't quite fit with their evolving understanding of what planets should be. Herschel proposed the term asteroids for these smaller objects, and Ceres, along with others like it, was downgraded from planet to asteroid. The case of Uranus, on the other hand, was less controversial. It remained firmly in the planetary category, benefiting from Herschel's influence in the field. This was an important precedent because it showed that the definition of a planet was not just about size or visibility, it was about an object's role and behavior within the solar system. But even after these reclassifications, the story of planet definitions wasn't settled. In 1930, Clyde Tombaugh discovered Pluto, an object smaller than Earth's moon and with a highly eccentric orbit. Pluto didn't quite fit in with the other planets, but it was declared the 9th planet nonetheless. However, just as it happened with Ceres, astronomers began to question Pluto's planetary status as more information about the outer solar system came to light. The discoveries of Uranus and Ceres had already shown that the solar system was more diverse and complex than early astronomers could have imagined. And Pluto's odd characteristics, its small size, its orbit that crosses Neptune's, and its composition, began to raise questions about whether it truly belonged in the same category as the giants like Jupiter and Saturn. As we moved into the 1990s, the debate over Pluto started gaining momentum. The discovery of objects beyond Neptune, many of which shared characteristics with Pluto, indicated that perhaps it wasn't the only object of its kind. These trans-Neptunian objects seemed to be part of a larger population in the distant reaches of the solar system. One of the most critical discoveries came in 2005, when astronomer Mike Brown found Eris, an object nearly the same size as Pluto but even farther from the Sun. Eris forced astronomers to confront the issue directly. Could we continue to call Pluto a planet if Eris, so similar in size and composition, wasn't also granted that status? This set the stage for the dramatic decision at the 2006 IAU meeting, which would forever change how we think about planets. As we can see, the history of planet classification is one of constant re-evaluation and adaptation, reflecting the growing complexity of our knowledge. It's not just about what we see through a telescope, it's about understanding the broader dynamics at play in our solar system. The 1990s marked a turning point in the way astronomers viewed Pluto and its place in the solar system. As new technology allowed for deeper exploration of the distant regions beyond Neptune, a variety of small, icy objects were discovered that resembled Pluto in many ways. These findings opened up an entirely new area of study known as the Kuiper Belt, a vast region of space filled with objects that, until recently, had been largely invisible to us. Pluto, once thought to be a lone oddball on the fringes of the solar system, now appeared to be part of a much larger family of distant objects. Among these new discoveries, the most significant was Eris, found in 2005 by astronomer Mike Brown. Eris, like Pluto, orbits the Sun in a region far beyond Neptune. It was nearly the same size as Pluto, and this discovery presented a dilemma. If Pluto was considered a planet, should Eris be one too? And if not, what did that mean for Pluto's status? These questions ignited a fierce debate within the astronomical community, as it became clear that the definition of a planet needed to be revisited. This debate came to a head in 2006 when astronomers from around the world gathered in Prague for the International Astronomical Union (IAU) meeting. At the heart of the discussion were two distinct camps, the geophysicists and the dynamists. These groups had differing views on what should define a planet. The geophysicists argued that a planet should be defined by its physical characteristics. In their view, if an object is large enough that its own gravity shapes it into a nearly spherical form, it should be considered a planet. Under this definition, Pluto would remain a planet, along with Ceres and other large, round objects in the solar system. This approach emphasized the internal properties of an object, focusing on its size, shape, and structure. On the other side were the dynamists, who believed that a planet should be defined by its role and behavior within the solar system. According to this view, a true planet must not only be spherical but also dominate its orbit. In other words, it must have cleared its orbital path of other debris. This definition would exclude Pluto, as it shares its orbit with other objects in the Kuiper Belt. The dynamists argued that planetary status should be reserved for objects that are gravitationally dominant in their region of space. The debate between these two camps was intense, with strong arguments on both sides. The geophysicists' definition was more inclusive, allowing many objects to be considered planets, while the dynamists' approach was more exclusive, limiting the number of objects that could qualify. In the end, the IAU adopted a definition that included both criteria: a planet must orbit the Sun, be nearly spherical, and have cleared its orbit of other debris. This compromise effectively gave the victory to the dynamists, as Pluto did not meet the third criterion. While it orbits the Sun and is nearly spherical, it does not clear its orbit. It shares the Kuiper Belt with many other objects of similar size. As a result, Pluto was reclassified as a dwarf planet, a category that also includes Eris and Ceres. This decision was groundbreaking and controversial. For many people, Pluto had always been the ninth planet, a familiar part of our solar system. Its demotion to dwarf planet status felt like a loss, and for some, it sparked frustration and disbelief. How could a celestial body that had been taught in schools for decades suddenly lose its status as a planet? But for astronomers, the decision was a necessary step in making sense of the new discoveries in our solar system. As technology improves and our ability to observe distant objects increases, the need for clearer, more precise definitions grows. The reclassification of Pluto wasn't just about Pluto, it was about developing a framework that could accommodate all the new objects being discovered at the edge of our solar system. This part of the story highlights the ever-evolving nature of science. As our knowledge expands, so too must our understanding of the universe and the rules we use to describe it. The reclassification of Pluto in 2006 didn't just settle the debate, it sparked new questions and ongoing discussions. One of the main issues that remains is the ambiguity in the definitions provided by the IAU. Terms like nearly spherical and cleared its orbit are not as clear-cut as they might seem. For example, how spherical does an object need to be to qualify as a planet? And what exactly does it mean to clear an orbit? Critics argue that even the current planets in our solar system don't all perfectly meet these criteria. Take Mars, for instance. It shares its orbit with small asteroids, known as Trojans, yet it is still classified as a planet. Pluto, on the other hand, captures only a small fraction of the mass in its orbit, which disqualifies it. This inconsistency fuels ongoing debate within the astronomical community about whether the definition of a planet needs further refinement. Moreover, the distinction between dwarf planet and planet adds another layer of confusion. The term dwarf is often used to describe smaller versions of a type, like dwarf stars or dwarf galaxies, but these objects are still considered stars or galaxies. In contrast, dwarf planets are not considered planets at all, which seems contradictory to some. This ongoing discussion highlights the challenges of categorizing celestial bodies in a system as complex as our solar system. As our understanding of the universe grows, so too does the complexity of how we define it. The reclassification of Pluto is a prime example of how scientific definitions must evolve with new discoveries. While the IAU's decision brought some clarity, it also exposed the difficulties of trying to fit the dynamic, ever-changing cosmos into rigid categories. The solar system is full of objects that challenge our definitions, from dwarf planets to asteroids and Kuiper belt objects. What's clear is that science is not static. It's a process of constant questioning, re-evaluating, and refining as we gain more knowledge. As we explore further into space and make new discoveries, our understanding of what constitutes a planet, or any celestial body, may change again. So, is it time to rethink the definition of a planet? Perhaps. But for now, the debate surrounding Pluto reminds us of the importance of embracing the unknown and staying open to change.